sum in C sharp. The problem says given an array of integer nums and an integer target, return two numbers that adds up to your target. So in this case my target is 9, and you see 2 plus 7 adds up to number 9. Another example is 26. Here 11 and 15 will add up, making a 26. So an approach that we can think of is start iterating on the list, and as you iterate you add it with the next element in the list and see if your target is achieved. So in case of 9, I go on 2 and add it up with 7. So you get your result here. In a slightly complicated target where you may not get your answer in the first go, you will have to check your first element with all the numbers in the list until you achieve your answer. For example, here 2 plus 7, 2 plus 11 and 2 plus 15, none of them give me a count of 26. In such case, we'll have to go to the next index and do the same process all over again. 7 plus 15. Still, none of them gives you your target. In this case, you will go on to the next index and do the same process all over again. But this time you have your answer as 26. 11 plus 15 is 26. Now, a simplest solution in the code will be writing two loops. One that goes from 0 to the count of your list, and another loop that starts from your current the next element of your current pointer all over to the end of the list, and you compare here if your number at ith position and number at jth position equals your target. If yes, then you have your result here. If no, you keep on doing the same thing until you reach at the end of the list and you have your answer. This may look like a straightforward approach, but this is a brute force solution, meaning you see this inner for loop runs from a certain position all the way to the end of the list. That means it is running n times. N means the length of your array. Similarly, the outer loop also does the same thing from 0th location all the way to the end of the list. So again, it runs n times. When you do the math, it is running n times n. For every element you access to the other elements of the list. Similarly, with all the elements, this comes out to be n square complexity. Now, n square complexity is very expensive for a simple problem like this. A better way to solve this problem, we can use something called hash set given in C sharp. In hash set is a data structure where you can store unique values. So if I store all my list elements in a hash set, the problem becomes easier. So this time I can slightly modify my approach. So you know that I need to have at least two numbers that adds up to my target. So instead of this, I can slightly modify this, and I can have my target minus any one number will give me my second number, right? So we'll keep this approach. We'll use this expression this time in our solution. Now let's say I am on the first position of the list and my target is 26. So does 26 minus 2, do I have this number in my hash set? In this case, it's not. So I move on to the next element, 7. 26 minus 7. Do I have 19 in my hash set? The answer is no. So you move on to your next index, 11. 26 minus 11. Do I have this number in my list? The answer will be yes. So you see, we have only traversed 3 times in the list and you have got your answer. And there is only one loop required to iterate on your list. Given that you have all the elements from the list in a hash set. We'll see a small code for this solution. I have a list with some numbers in it and my target as 26. And the function will begin here with declaring a hash set of integers. This is coming from your systems.collections namespace. I will first put all my numbers from my list in the hash set. Simple. And now I'll write the actual implementation that I'm going again all over from my numbers in the list. This time I simply check if my hash set, before that let's calculate the complement, which is the expression here, target minus num1 equals my num2. So this is our complement, and my target minus num that I'll be traversing on every iteration. Is this complement present in my hash set? If it is present, I simply return my number itself and the complement. If no, we keep on traversing until you get your target. Let's run this program and see. You'll see 11 and 15 are the two numbers that will add up to your target 26. Is the third iteration here. Now, a slight modification to do some problem is that you may not be asked to return the number itself, but instead their indices, which is in our case will be 2 and 3 for 11 and 15. So now I need to also maintain the indices with my actual elements. But because hash set does not allow you to keep multiple numbers at one place or a pair of numbers at one place, there's another data structure called dictionary, sometimes called map or hash maps. This is used to keep pairs of elements. So we'll slightly modify this program and convert our hash set to a dictionary with their indices. You can see all these indices are kept with their numbers. And this time I'll remove my hash set implementation. We will keep a nums index pair. We will run over the list once. This time we cannot use the for each loop because we want the indices with their numbers. I'll simply store these numbers and indices in my nums index pair, and we begin with our main implementation of your search operation. So calculating the complement, if my target minus my current number of the iteration, if this is present in my nums index pair, then you have your answer. So I want to return the index and my number present in the dictionary, which is the index of that complement. And similarly, we keep on doing this until we find our target, and then we simply return and print. So we'll see the output. You see, this time you see 2 and 3, which are the indices instead of the numbers. So 2 and 3.